Hello, today we're going to be talking about linear and quadratic regressions and how we do those in Desmos, which is built into the Virginia SOL test, Algebra 1 and Algebra 2, and also geometry. So the first thing we need to understand is whether or not we're looking for a linear regression or a quadratic regression. And we're going to be given just a table of data, something like this or something like this. And we need to be able to determine whether or not we need to do a linear regression or we need to do a quadratic regression. So let's take a look at the first set of points first, the first table. So this is the first set of points that we have. And we can see here as we are looking at y values that as we are going across x, y is only going up. And if it's hard for you to interpret data from a table like this, you can add the table to Desmos and look at the points and see how they physically look on the graph. So I'm going to start by opening Desmos, desmos.com/calculator. You're going to hit the plus button here and you're going to add a table. And you'll see that there's an x1 here and a y1 here. So the number of lines, you're given here that is x, and you're given that the cost is y. So you're going to enter the x values in the x column, 4, 5, 6, 7, 8, 9, and the y values in the y column, 10.4. And I'll pause this. I won't make you watch this whole thing. Through the magic of the computer, we can now see the table, the data is plotted. And if you look at how these points look on the graph, you can see they just go up, 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 up. And if the points are either going all just up, 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 or down, 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 and they stay in a continuous line, you're going to want to do a linear regression. So to do a linear regression in Desmos, we're going to add an expression. You want to type in y, and then you're going to hit the underscore button, and that's going to give you that little sub there, 1. And you can see this says that you're looking at a 6-element list. Well, this is pointing to this table of values here. So the 1 here and the 1 here have to match. If you need to do another regression, you're going to want to clear all this out. And I'll show you how to do that. You're going to hit the tilde button, which is in the upper left-hand corner of your keyboard. AX underscore 1. So again, you want that little subscript there, plus B. And you may recognize this is the slope-intercept form of the equation. And now you have your regression. So this 1.85 is the slope of the line, and the B is the intercept of the line. And I'm going to show you a couple things that you can do with this information. So if we go back and look at the original problem, it says the table below shows the cost, y, for a specified number of phone lines. And this table ends at 9. What if you wanted to know what the cost would be if you had 20 phone lines or 25 phone lines? Well, Desmos can show you that. So you're going to take your line of best fit, add an expression, and instead of having the tilde, we're going to make it an actual equation where we say y equals 1.85, and I'm getting that number from right here, 1.85, x plus 3, which is the slope-intercept form of the equation. Now you should see that the red line is covering the black line that was the linear regression you made, and it does. And if you take this expression, go up to this, I call this the cog, I don't know what it is actually supposed to be, hit the cog and convert this into a table, well, now it's going, you can use this table to take any input. Say you want to know how much 20 lines would cost. 20 lines would cost $40. How much would 25 lines cost? 25 lines would cost $49.25. So if you have a question that says something such as, given the input 35, what would the potential cost be? Well, you can answer that, 67.75. And because I'm done with this problem, I'm going to hit all these X's over here and clear all this data out of my calculator so that I'm not accidentally referring to another set of values if I want to do a second regression. And so here's another question. Look at the table. What do you notice about the y values? Is the equation linear or quadratic? Okay, so as we're moving across, in x values, as we're moving across, our data is going from 1 to 3 to 7 to 11 to 12 to 11 to 6 to 3. Well, what shape does that data start to make? And you can see this in Desmos if you're having a hard time visualizing it. So I'm going to go to the plus sign. I'm going to add a table. I want this table to be a different color this time. If you want to change the color, you can click there. Let's make this one purple. And we're going to enter the x values again. So I'm going to go this time point by point. I have 1, 1. I have 3, 3, 4, 7, 6, 11, 7, 12, 10, 11, and I can see the points starting to come on here, and they're going up and they're going down. 12, 6, and 14, 3. Whoops, 3. And I'm going to zoom out so that you guys can see the shape this is starting to make. So if my points are going up, up, and then they reach a peak and start to go down, or if they start to go down, reach a peak at the bottom, the opposite of a peak, an under peak, I'm not sure what you would call it, right? A dip. If they reach a dip and then go back up, then you are going to do a quadratic regression. So a big part of this is just going to be, what shape do the points start to make? And do I need to do something that's going to have just x, or do I need something that's quadratic, meaning x squared, right? Quad means squared. And quadratic regression is going to work very similar to a linear regression, but you're going to have a square value in there. So again, I see my data in my table here has 1, so I need to refer back to the 1 in the table. And I'm going to start with y underscore 1. I have an 8-element list, which is exactly what I see up there. In the upper right left-hand corner is the tilde, and then a, and you can put in both ax. If you hit the shift key and 6, the little caret there will give you the squared. And you can still put in both the superscript of the 2 and the subscript of the 1. So you want to hit the underscore 1 so that you're referring back to this x squared. And every x is going to need that 1 subscript that refers back to the table. So plus bx sub 1 plus c. And that's your quadratic formula, and this is your quadratic regression. And exactly like you did before, you can write that as an actual equation. I'm going to round this to the 100th. I'm going to add an expression, and I'm going to say, instead of using the tilde, I'm going to say y equals, my a value is right here. I'm going to say negative 2.4, or 0.24, sorry, x, and again, shift key and 6 is going to give you the superscript, plus 3.80, that's my b right here, x minus 3.92, which is my c, my constant over there. And the green should start to cover up the purple, which it does. So the equation I wrote is very close. It's rounded, so it's going to be close to it, but one should cover the other. That's how you know that you're doing it right. And you can hit this little cog again, convert this to a table, and then again you can say, oh, what would, if the input were 25, what would the output be? Negative 58. If the input were negative 25, what would the output be? Negative 248.92. So you can use this to estimate other outputs. And again, I'm going to clear out this whole table, and I'm going to give you one little bonus feature here that you can do with a regression. So say you're given the question, find the slope of the line that passes through the points 0, 5, and 12, 14. Well, you could do that. You could, if you can remember the slope formula, right? Change in y over change in x. You could certainly do it that way, where you say minus 14 minus 5 divided by 12 minus 0, which is 0.75. I can convert that over to a fraction. But what if you can't remember the slope formula? You're like, I don't remember the slope formula. I don't know how to do this. You can use a linear regression to calculate that slope. So you just add a table. You're going to put your 2 points in, 0, 5. You have 12, 14. And you're just going to do a regression. You say y sub 1 tilde a x sub 1 plus b, and the coefficient on this x value here is 0.75, and if I don't know that 0.75 is 3 over 4, I can use Desmos. I type in 0.75, I go over here to the fraction button, and I can convert that to a fraction, and the slope of that line is 3 over 4, which is the same thing that we found using the slope formula. All right, I hope this helped. Thanks for listening.